Okay, Srini, hope you are refreshed.
Hello.
Hello, let's finish it then. Okay.
Hello.
Yeah, hello. Have you done question 2? Essay question?
Yeah, I did a bit.
Did already, ah?
A bit.
Where did we stop? Can you remember?
Nope.
Okay, doesn't matter. Since you cannot remember, we will review back. State Faraday's law of electromagnetic induction and Lenz's law. Okay, so you can remember. Usually each of them 1 mark lah. Yep, can remember?
Faraday law of electromagnetic induction states that when the magnetic flux linked with the conductor changes, the EMF, which is directly proportional to the rate of change of magnetic flux linkage, is induced in the conductor.
Lenz's law?
Lenz's law.
Lenz's law?
Lenz's law states that the direction of the induced current is such that it produces a magnetic field to oppose the change in the magnetic flux that induced the current.
Alright, Lenz's law, any induced current or EMF, induced EMF will be established in a direction so as to produce the effect that opposes the change that is producing it. Okay, how do you define mutual inductance? All this must be your scoring point by your fingertips. Yep. Mutual inductance. Cannot remember. Yeah, defined as ratio of EMF induced in the secondary coil to the rate of change in current in the primary coil. Okay. Diagram shows a coil of NS turned around the middle section of the long solenoid of NP. This NP, this NS, number of turns, and length L, as a length L. The solenoid and coil have the same cross-sectional area A. Derive an expression for mutual inductance between the solenoid and the coil. I hope you know how to do that. Okay, I think we have done that before. So just go briefly review. Now with your solenoid formula, replace it with the formula that's given, primary NP over L. That's I. And secondary flux, BAN. B, there's your B. And then N is NS. Then there's your A. And okay. So flux linkage is MI. And compare to get the answer. Okay with that? Yeah. What am I doing? Okay with that?
Okay.
It seems to be telling me some problem. How much thinking? I just only one. Okay, we'll carry on then. And after that, solve the problem. A rectangular coil of 50 turns and area. That's your area. Remember to change to meter. Place in the plane perpendicular to uniform magnetic field. B is 2.4 Tesla. The coil is then rotated through an axis perpendicular to the magnetic field with an angular velocity of 5 radian per second. That's your axis of rotation. They are very kind to you, for you. Find the magnetic flux linked with the coil. What formula to use? Yep. What formula should I use? PAN, no? Yeah. PAN to calculate the flux linkage. Right? B is given. As your B. As your area. Change it to meter. 10 to the power minus 4. 50 turns times 50. Derive an expression to show the variation of EMF induced in the coil with time. Yeah. What expression should I write, or how should I write it? Yep. Can? No? Any idea?
No.
Remember? Right? You start with maximum flux linkage. So you start with your cos. And EMF is just that formula, Faraday's law. Right? That's the reason why they ask you to define Faraday's law. You are going to use it, then differentiate it. Right? Differentiate your EAN. I done something wrong. Yeah. Differentiate it. You differentiate a cos because sine, negative then positive. Then you still got your sine omega t. Omega is 4 pi. Right? And then when you differentiate omega t, you still got 4 pi there. Right? BAN is that. BAN. That's all. Can multiply out. Okay, if okay, let's go to number 4. If got time, we will go to number 4. I think we won't bother about this one. Since we have just done that. That's what they want. Okay, diagram shows a coil, a wire of radius. That's the radius of that coil there. In a uniform magnetic field, that's the value, the strength. The plane of the coil is perpendicular to the magnetic field. The magnetic flux density is then reduced to, you change your B from 0.2 to 0.15. What's the EMF induced in the coil? Okay, what formula to use? Basically, they ask you to define. So they want you to use a formula. That's why they ask you to define. So what formula to use? Can? Yeah, Faraday's law. Then calculate replace your flux linkage. Yeah, B, N is 1, A is constant, B is the one that is changing. Yes, BAN, this flux linkage is BAN, N is 1, A is constant, B is the one changing. Put in your value. Right? 0.8 to 0.2, and then the time is 0.15. Area of coil is pi r square. This one, as your R. Calculate up. As I said, don't need to worry about negative sign. Okay, still explain the direction of the induced current. That's direction. Where is the direction of the induced current? Yeah. Can or not? Can or not?
Yeah, can
Yeah. Tell me, no, then.
E equals to negative D. What's that symbol? dq over dt. I mean that weird symbol and then over dt.
So that's the first one we have done already. Now we are asking you the direction of the state and explain the direction of the induced current.
Oh, it's in clockwise direction.
Why? Explain.
When B reduce magnetic flux through the coil decreases.
Say again.
When B is reduced, magnetic flux through the coil decreases.
Where got that? Explain like that. You want to decrease, so the induced current will flow. Try to make sure you increase the magnetic field. Clockwise is correct. Since the field is decreasing, to maintain the field, the current or EMF must be clockwise, so that the field is in the original direction. Okay, now.
Okay.
State, I think we've done that. The electric motor is connected to a 6-volt supply. At time t equals 0, when the switch is closed, the current is 0.25 ampere. When the motor achieves a speed of 30 revolutions per second, the current is 0.18 ampere. After the motor is loaded, the speed is 20 revolutions per second. Okay, this is a challenging question. Calculate the armature resistance of the motor. How to calculate? Yeah. How to calculate the resistance? Yes, Srini, how to calculate the resistance of the armature?
V equals to IR.
No rotation, so it's just a maximum current. V equals to R is V over I. Put your value of 6 volt there. 0.25. There's no rotation, so that's the largest current. And get your ampere. The back EMF when the speed of the motor is 30. So what formula to use? Yep, can remember?
E equals to V minus IR.
V naught equals to IR plus back EMF. Then back EMF is V naught minus IR. Then put in your value. V naught is 6 volt. Supply voltage. Current is 0.18. R we have already calculated. So we got the answer. The back EMF when the speed is 20. How to calculate the back EMF when the speed is 20? What formula to use? Yeah. EMF is proportional to frequency, no? Yeah. Use that. Form your formula. That's the second part. That's the first part. Okay. Take this one down. It's a constant. And put in your, you want to find your back EMF and the frequency when the speed changes. Take this one across there. So the first one is 1.68. And then it changes to 20. Initial was 30. So you got 1.112. So how to calculate the output power? Yeah. Output power? Yeah, output power, how to calculate? Yeah, when it's loaded. Yeah, when it comes 20. How to calculate the output power when the motor is loaded? Yeah, forgotten already. We have done today already, earlier. Calculate your back EMF. We already calculate your back EMF. Now we can calculate the current. We need the current times your back EMF, and we can get your output power. Okay, there's your 6 volt back. 6 volt. There's your back EMF. Your R is 24. Calculate that current and power output is your back EMF E2. That's your current. Okay, can. Yeah. Are you all right? Anything not clear?
Yeah, I'm all right.
Okay, we are all right. Let's just start with our AC for a little bit, just to get you to review. Yeah, more or less
AC?
completed. Anything else you want to ask?
No.
Since we got a bit of time, we might as well. Make sure you review your the topic since your teacher have taught you already. So that you force it in again second time or third time. Okay. Let's go over. Okay, the last topic, alternating current circuit. Right. First, we want to look at alternating current through resistor, alternating current through inductor, alternating current through capacitor, and of course, we will look to resistor and capacitor, resistor and inductor, and then after that, through the three of them in series. So you are all much luckier than us. Us, we have to study parallel some more. So your syllabus have been reduced. Syllabus, alternating current through resistor, explain the concept of root mean square value of an alternating current, and calculate the value from sinusoidal case only, derive expression for current from V, that is your supply voltage, V equals V naught sine omega t, explain the phase difference between current and voltage for pure resistor, derive and use a formula for power in an alternating current circuit which consists only of pure resistor. Okay, remember your value of constant. Okay, part of the problem with your syllabus, it doesn't tell you where is the uses. AC, we usually generate the power station. Then before we send it out, we use transformer to step it up so that less energy is lost during the transmission. Then before we reach the house, we use transformer again to step it down. And there's another transformer here to step it down. And in the house there, you want to charge your handphone, you use your adapter, right? Or we call rectification. This one is normal in your syllabus. Page 228 in your note. In many countries, electrical energy is supplied in the form of alternating voltage supply. Basic terms used to describe alternating current are introduced. Right? Transformer, we have already studied. Together with the use of transmission energy. Transformer, we have studied that. There's a reason why we studied transformer. Then rectification is no more in the syllabus. So we can forget about that. That is called rectification. Changing from alternating to direct current. Okay, no more in syllabus. Okay, alternating current electricity. Alternating current electricity is a type of electricity commonly used in home and business throughout the world. While direct current flows in one direction through a wire, AC electricity alternate means change direction. Its direction back and forth. The direction alternate between 50 and 60 times per second, depending on the electrical system in the country. Right? Malaysia is 50 Hz. America may be 60 Hz. So it depends on the country, they are the one to make the choice. AC electricity is created by AC generator. This is just for general knowledge. I don't need to worry about all that, which determine the frequency. What is AC? What is so special about AC electricity is that the voltage can be radially changed. Right? Can step it up or step it down, thus making it suitable for long distance transmission than DC. DC, you cannot step it up, cannot step it down. Right? You can step it down, but you cannot step it up. So AC can employ capacitor and inductors in electronic circuit. Right? We don't have to worry about that. That's just to give you application why we study what you study. Okay, some of the terms you're likely to encounter. Direct, one direction, always constant. Alternating, changes direction. Right? This is called pulsating. It's still direct current, but it's up and down, not constant. Right? The other one is called variable. This one, variable. Okay, mean value. Right? You have a function there. It repeats itself after a time of t second. So usually we focus on one side. Right? We want to find the mean value of the function. We find this is the area of the graph. Right? Integrating it. So we want to make the average current the same. So average current the same. So it's just area of this rectangle equals to area of this under the graph. Right? That's what this one means. You don't need to know all this. This is just for your, in case you, right? That's the area of the rectangle. In case you want to go a bit further. But as I said, not necessary. Okay, you should be able to write this equation. This is a cost graph. Right? Instead of 0, you push it up by A. Right? That's your A, your height A. That's why we have an A there. And then this is a negative cross graph. There's amplitude B. That's all. So area under the graph is that equation. You integrate that, that's all. That's the area under the graph. Right? Mean value, we want the average voltage that is constant times your period. So area of this rectangle, the blue rectangle is the average. Okay, that is the general idea of average value. Okay, what is the mean value of the curve? Yeah, what is the mean value of the curve? This is a sine graph. That's your 0 line. This is positive maximum. This is negative minimum. So what is the mean value?
0.02 second.
No. That is your hill. That's your valley, empty. Now you cut the hill and put it to a valley.
So T over 2.
So 0. Okay now.
Oh,
Mean
okay.
voltage is 0. Yeah. How about this
Yep.
case? I just change the axis, call it power. So what is the mean power? Yep, mean power. Same idea. Right? Here I cut the hill, cut it off and put in this valley there. So it will be zero line. So here the same thing. I cut this hill up and place it in this valley here. Right? So the height is all half P naught. So the average is half P naught. Okay or not?
Okay.
Okay, we will stop in a short time. Right? That's your AC generator. This is just a simplified form. Usually we use water or steam to turn the coil. Right? Coil rotates in a constant field at constant angular frequency omega. It cuts the magnetic field and an alternating current is induced in the coil. Okay, so we can represent it as I naught sine omega t. So direct current, right? One direction, constant magnitude. This alternating current changes direction, positive, negative direction. One direction is positive, one direction is negative. Right? Alternating current is an electric current that is periodically reverse its direction in the circuit with a frequency independent of the constant of the circuit. Right? We don't have to worry about the resistor, the capacitor, the inductor there. That's what it means. It is determined at the power station frequency. Okay, some of the terms there, and we will stop. Right? If there's your current, there's your time, right? There's your period, there's half a period. Right? Peak current, I naught or IM, M for maximum, right? Is the amplitude of the current. Right? Amplitude. One cycle from zero, increase, decrease, decrease, and then go to zero again. That is one cycle. It's not one cycle. Frequency is the number of cycles per second. And period. Okay, period is one over frequency. Okay. So during the old days, we use small I lah. But your time we don't bother. We use small I for variable current. Right? But for you, you can just use I lah. Right? The thing to remember, you can either write this in terms of time, or you can write in terms of time. You can use theta or omega t. Then this one can be 0, pi radian. Sorry, pi over 2 radian. This is pi radian. This is 3 pi over 2. Right? The period t is just equal to 2 pi radian as well. Right? Or 360 degrees. Okay, that is your peak current. Okay, so remember, instantaneous equation is given by this equation. I know it's the maximum of peak current. T is your time. Omega goes to 2 pi f. Angular frequency, okay. What is the angular frequency? Calculate for me. 18.2. If the frequency of voltage supply is 50 Hz, what is the angular frequency? Yeah. Can or not? Okay. That's all. Okay, that's all. Omega is 2 pi f. Put in your value and calculate out. Okay, looks like you are tired already. I might as well stop here and carry on tomorrow.
Yeah, okay. Thank you, teacher.
Anything else you want to ask?
No, teacher. I'll ask you tomorrow.
So tomorrow 1 hour lah. We see you tomorrow.
Yeah. This is why I don't want to take 2 hour teacher. I feel tired fast.
2 hours is too stress for you. It's better you have 1 hour and then another hour the following week. You want 2
No,
hours?
actually, I mean, not your fault, teacher. It's just that I can't focus 2 hours.
That's why I say you cannot focus. It's better 1 hour. For me, no problem. Okay, so I see you tomorrow.
Okay. See you tomorrow, teacher. Thank
Review
you.
through.
9 o'clock. Okay.
Yeah, 9 o'clock. Review through what you have learned.
Chapter 18. Okay.
Then you will be better able to understand what I teach you. Okay, I'll stop here. Bye bye.
Bye bye. Thank you, teacher.